Good afternoon, everybody. Welcome to another Turning Tuesday. Today, we're going to go over this extravagant part. And just before we kick this off, I'm going to go ahead and let you guys know if you want to see the milling portion of this, we do a Mill Turn Thursday course as well, where we're going to cover the machining out of this actual funnel. So let's go ahead and switch from our design to our manufacturer workspace. And we're going to start by creating our setup. In this case, I've made the mistake, oh no, of being in the milling tab versus the turning. It's not a big deal. So you guys know muscle memory at its finest is kicking in here, but we're going to go ahead and say turning or mill turn. We are going to be in our primary spindle, which means I'm actually going to flip my Z-axis here. And again, we're going to be in that primary spindle in this case for the milling also later on Thursday's class. So scrolling through here, we have our body selected already. We're doing a spun profile. Again, my stock size, let's go ahead and bump this up just a hair. Let's say 6.5. And then I am going to work with a little bit bigger slug here. So we're going to go ahead and say, actually, you know what? 3-inch actually fits very well. And we can hold on to this right here based on our machine. So now that we've actually done all of that for our setup, let's go ahead and start creating our toolpaths. So very first thing most of you are going to do is a turning face. However, on a part like this, I might not actually do a turning face because that profile that we're working with is such a kind of mitered angle and everything that it might be easier for me to go in and do a turning profile rough right off the start. And I'm going to show you a little trick here once I grab my tool. Again, we're just going with a simple right-handed tool out of the default library. We're going to work from the front of our part to the back. We do want to make sure that we're actually working from the stock front in this case. And the reason for that is because when we go to our passes tab, I'm actually going to tell it vertical passes versus horizontal passes. And what's going to happen here now is we're going to go ahead and clean up our depth of cut. So let's go ahead and change that to 50. We're going to use even depth of cuts. And then I'm going to go ahead and hit OK. And what you're going to notice is we're now constantly working outside in, pushing across the actual x-axis all the way down our part. Now, if we wanted to redo this in a more traditional approach, again, let's go stock front to model back. Let's go horizontal passes, again, with the same 50 thou step down. You're going to notice it's still going to give us about the same amount of time when it comes to cycles, so neither way is right or wrong. However, I could, in the case of this second process, also add in a facing cycle if I really needed to. And the reason why I'm not doing a facing cycle is if we look at the nose of this part, it's so rounded that it's almost a wasted cycle. So I'm going to go ahead and delete this. We've now profile roughed the outside. Let me go ahead and get my stock turned on too so we can see this as we go through this. From here, we've done our rough. We're going to do our finish now. And again, what I'm actually going to do is I'm going to work backwards, which is going to be a little wild to some of you, but we're going to work from the model front to the model back. I'm going to go ahead and say, front to back, back to front instead. And what this is going to allow me to do is to back drag this surface with my tool. So again, we're just doing one step over, no spring passes, nothing really needed here on this part. We're going to allow Fusion to do its calculation and pick up where it needs to start and where it needs to stop. I am getting a warning here, and the warning is because the lead on this particular part is actually making contact with the stock. I would want to go in and change and go ahead and say allow lead to cut stock, and this will actually fix that problem in most cases. So now that we've done this, a couple of things that are happening is we're actually coming in too far back. We're also machining that shoulder up there. And we don't want to machine that shoulder because we want to actually hold on to that when we're creating this part. So what I'm going to do is I'm now going to go in and let's fix our roughing cycle. So we don't want to go model back. We actually want to go to a selection. And that selection is this face. And again, we could go ahead and hit OK. And now you can see we're only machining to that flat. Again, we're going to go into our facing profile and do the same thing. We're going to go ahead and say selection. Again, using that same exact face. And as you can see here, we're now stopping short because of our lead out or lead in situation. So we can actually do some tangential extension type work here to be able to clean this up and fix it. We also want to pay attention very closely here because we are stopping at the nose of our part because we're working back to front. So we want to make sure that we actually go all the way down the front of the part as well. So let's go in and fix that because again, this is where everybody gets confused. We're not changing the back to the front because all we're doing is constraining this in Z-axis right now. So what we want to do is we want to go ahead and say we want to work from stock front in our finish cycle again. And then what I want to do is possibly do a tangential extension as well based off what it is, how we're going into our part. So if we go ahead and say 0.5 extension on the back, you're going to notice, again, we're working back to front. This is why what I usually advise to people is to always leave this front to back until you figure out what it is that you're trying to do. And as you're seeing, my lead is now plenty big enough going front to back, and we're starting down here at this beginning point without a facing cycle. So let's go ahead and now switch it back to front. And to see this run, we're going to go ahead and grab both toolpaths and we're going to simulate this. And now I'm going to go ahead and switch over to comparison. I prefer comparison. We're going to get our collision checking on. And then I'm going to turn my accuracy down just a little bit so that it's a little nicer on my computer as we simulate through. So as you're seeing, we're doing that outside in, kind of roughing down our part. From here, we're going to go ahead and come back with that finish cycle. And what that finish cycle is going to do is now back drag our part, giving us a nice clean flange and face all the way down and even all the way down to center in the event that we're going to drill this from this back side. So from here, we're going to go ahead and hit exit simulation. We're going to go back into the world of Fusion. We did do a lot already to this part, but we're now going to drill this front face and we're actually going to bore this inner area. And this is going to make it much easier to keep that nice clean edge all the way around and then use our fillet on the backside to blend everything out. So again, we're going to go in and we're now going to say drill. I am going to start with a relatively large drill. So let's go into my library. Let's see what we have out there for drills. So I'm going to go for that big 1-inch drill that we have right here. I'm going to go ahead and pick the face that I want to drill. One thing to be cautious of, guys, is because that face is below due to the fillet, we want to make sure we say auto merge hole segment. And we may also want to double verify that we're not starting down inside of that actual part. So in this case, we're turning on auto merge hole segment and nothing is actually changing about my toolpath. So I may want to make sure in the heights tab that we start off with a model top. And the reason for that model top, as you can see now, it jumped out just ever so slightly, is we want to make sure we are at the furthest out point right here, touching that. Because again, we faced that off. We haven't done anything in that face. We don't want to worry about crashing our tool. We also want to go to hole bottom, but we do want the drill tip to go through the bottom. And then we do want to go an additional little distance past that. So I'm going to go ahead and give this an extra 100. And that is so when we go in, and you know what I'm going to do? Let's go ahead and hit OK. And let's go in and do a section analysis based on one of our planes. Let's go ahead and flip this. There we go. Now we can see what's happening inside of our part. So again, as now we have that split view of our part. The corner of our actual drill is making it past that inner fillet when we blend it back the other way. And now we can go and do our actual boring cycle. So again, I do need to remember a few of these dimensions based off what we're doing. But let's go in and let's do our turning profile rough. Let's pick out our boring tool. Again, I'm going to go with just stuff inside of my default library. We need an inside diameter boring tool. Again, based on my geometry, we're going to work from model front to model back. That's not the case here. We're actually going to say model front again, and then we're going to offset whatever that distance is that we want to use. So now this is a nifty trick here, is if you can see in real time how deep this is going. However, I can also set my drill to do the same thing to make sure that we're not making any contact. And I'm going to do this with an estimate, and then I'm going to go back and adjust my drill if need be. So let's say we want to go 300. You know what? Let's do this even an easier way where I can select. And what I want to select is the edge of that fillet. And then what I'm going to do is I'm going to send that past. Actually, we're going to leave the offset to 0, but I am going to tangential extension this by about 30. And what that's going to allow me to do is stay straight and continue into my part an extra 30. Our radii, if you guys haven't caught my other videos, this is where a lot of people have some troubles with your boring cycle. We're going to go ahead and leave this for now, but we're going to come back and fix it once we see the error that we're going to see. Again, I can adjust my step down. I'm not going to allow any grooving because I don't want to wrap around this fillet in here. So let's go ahead and get our toolpath and then go back and make our corrections. So as you're seeing is we're starting on center, which there's no point to start on center because of our drill cycle. However, we're also always retracting back to center. So if we were to go ahead and simulate this right now, what's going to happen is our tool is going to cause a collision on the back side. So let's get that cleaned up and fixed. So that we got our toolpath back open, we're going to go ahead and go into our Radii menu. And as you're going to see here is what I'm going to start with is we don't want to start for the stock inside diameter. What's happening is because we used a solid piece of stock, it's not a tube. There is no clearance from default in our setup. So I'm going to go ahead and go in, and I'm actually going to say I want to use a diameter, and that diameter is going to be 1 inch because we did use a 1-inch drill here to drill this out. So with that one little change, you're going to see a lot has happened to this actual toolpath. And now, as you're seeing here, is we're still rapiding back to center for our clearance. So we're kind of rapiding into the basic center line of our part. Then we're going out and doing what we need to do. So if I was to go in right now and actually simulate this, we're going to get extremely lucky with the fact that that tool comes in and the backside is relieved just enough to go out and bore out the inside without causing a collision. Now, in my opinion, it's a little too close for comfort. So let's go back and change that actual clearance / rapid point. So again, we go to our radii menu. I'm going to change the clearance to inner radius. And the reason for this is because it's going to roll it back over to this guy right here. And then what I'm going to do is I'm going to do an offset, and I'm not going to use -0.4. I'm actually going to bump that down to maybe 50. And as you're seeing now, that orange line represents our clearance from our blue line, which is our inner radius. So now if we hit OK, you're going to notice we're now rapiding down to this actual point, starting our boring cycle almost immediately, and then getting back out. So if we simulate that, oopsie, we went ahead and hit the tool library and not the simulation button. Again, playing this relatively slow, we're going to come into that point. We don't have to worry about actually rapiding in kind of weird or the backside of our tool getting too close for comfort. And we're now boring out the inside of that profile. So from here, we can do our finishing profile. So I'm going to go in and we're going to create a derive operation. We're going to go turning profile finish. The reason why I'm doing a derive is because I want everything like my radii to possibly carry over, my geometry of the depth and how far I want to go. So I'm actually just going to go ahead and hit OK and let this go to start with and see what I get. And again, I am getting an error here. Lead out has been modified due to gouging. And the reason for that is we're coming down and around and across that face. So let's fix that again. We go into linking. We're going to say radial extension. We're going to hit OK. And just like that, we're continuing that cut all the way to that inside diameter and then rapiding out of our part. So now that we've kind of done everything on this one side of our part, let's get our section view turned off. And we could check that. So I'm not seeing, and we're not going to do any of the milling here, guys. We're going to save that for the other side. So let's go ahead and just run this through real quick. And I'm only going to run this last cycle. There we go. It looks like everything on the front side here is actually done. Again, turn mill Thursday, we will be covering the milling portion of this. But we can now go in and flip our part over. So what I'm going to do is I am going to actually create a brand new setup. We're actually going to go to our secondary spindle this time. So in this case of our machine, it's going to come in and grab, and we're going to retract. And then with that, again, we want from preceding setup stock. I also want continuous rest machining. And a lot of you are probably questioning the fact that I haven't done the handoff yet, and that's okay. We're going to do that at the end because I like to get my paths on my part before I worry too much about that handoff. So from here, again, we're just going to repeat kind of everything we've done. However, we're going to do a few little tricks here. So I'm going to take my first 2 tool paths that we've already done, and I'm going to go ahead and copy those. So we're going to go ahead and right-click copy, and I am going to paste those down in my setup too. And the reason for this is what's going to happen is, one, I'm going to be prompted to regenerate, but upon hitting Control-G for the regenerate, what's going to go through is because of the actual boundary that we set, not to go past here, it is limiting everything that is happening with that tool as it comes up and around that part. So one thing that did happen here is because we are doing that geometry and we did do a tangential extension, which we're going to go ahead and change to 0 now. Now we're working back the opposite direction with everything going on. So again, this is kind of a neat way based on my stock size. We did those vertical passes for our roughing, and then we came back, we back drug this with our tool to be able to actually clean up and finish all those edges off. So from here, we're going to go now, and again, I'm going to go and steal this drill bit. We're going to go ahead and copy and paste that cycle again. I'm using Control-C, Control-V this time. We're going to go ahead and hit Control-G followed by that to do our drilling cycle. The only thing I do need to realize here is we are going all the way down to the end of our part. However, when we did our first cycle, we went a ways in, and that's because of whole top, whole bottom. So again, as if we go through and we actually say, I don't want to go to a bottom height of whole bottom anymore, I actually want to go to whole top, and notice how it shrinks up that cycle. Again, I don't need a breakthrough amount because I've accounted for that going back the opposite way, or the initial run-in. So again, holding control of my 2 drilling cycles, we do still have a little bit of an overlap, but it's not a huge deal here. You guys could have drilled that all the way through also in the first cycle, 100% up to you. So now that we're doing that, again, just some more copying and pasting here, we can get away with a lot. So again, I'm going to copy my roughing and finishing cycles. I'm going to regenerate those, and we're going to see what happens going back the opposite way. So again, because where we were picking our boundaries and wrapping around our toolpaths, we're now working back the opposite way and accounting for each and every one of those things. So let's get our section view turned on again. I'm going to go ahead and simulate this portion. And again, here's my boring cycle. Again, we're not rapiding to where the tool is on center and then moving out. We're actually rapiding more or less to the start of that boring cycle. And then all of our retracts are not crossing center line anymore. So we don't have to worry about the backside making contact with anything. So let's speed this up a little bit. Let's run down that inside bore. And then we're going to make our finishing profile. Boom. And just like that, we've now cleaned up the entire backside of this part. If we turn our analyze back on, we would see our entire cylinder. All of my chamfers and fillets, as long as that fillet is bigger than my tool radius, has been accommodated. So like that, we've gone in and we've actually turned both the inside and the outside of this part all in one shot. But I'm going to show you a little tip here. So instead of drilling this both ways, maybe you don't have 2 1-inch drills. I don't blame you. They're not cheap. We're going to go ahead and we're going to change our drilling cycle on the front half of this part to actually go, instead of whole bottom, model bottom. And what's going to be super neat about this is going to allow us that when we work back the opposite way, that continuous rest machining is going to pick up on that. So again, we're going to go ahead and regenerate some of these tool paths. My facing cycle is now going past the center line. If I wanted to, and this is up to you guys, I could actually save some cycle time here, again, by setting a diameter at my inner radius. That's 1 inch. And now you're going to notice that we actually stop that front roughing cycle short so that we're not wasting all that extra time. Given I'm also going to bore the inside of this, maybe I don't actually do that finish cycle all the way down. I'm going to stop my finish cycle at a selected profile, and that's just this inside radius here. And again, now we're cutting down our cycle time more and more. We've already bored out the inside, so we just have to go in and rough. Again, I'm going to just regenerate these for safety precautions to make sure that we're not crashing. And again, that's kind of a neat way that you could look at these parts and kind of streamline your process all before actually going to the machine. And this is the best thing about Fusion, in my opinion, is being able to visually offline program and have confidence in the code that you're producing. So now let's go back and let's go ahead and do our handoff. So what I'm going to do is I'm going to go back to the first operation and I'm going to activate that over here. And now I'm going to go in and I'm going to do a sub spindle grab. So what we need to tell the software is how far in do I want to grab this part. So we're going to feed into the stock front. And then in this case, it thinks we want to grab all the way back here at the flange. And that's not the case. What I actually want to do is I want to go to a selected point. And that selected point is going to be up to all of you, but I'm going to grab at the top of this fillet. And then I'm going to manually move this in the distance that I want or I want to set. Another thing you guys could do if you want a little more visual here, you could say, you know, I want to go off the front of the model and a certain distance. Either way, that offset is allowing you to adjust in to grab where you are not grabbing on that actual radius and causing problems or avoiding certain features that might be in your way. Now, based on this, I am also going to stop the spindle during the grab because we're not doing a part off. So no reason to do a live grab unless we have to. We're going to go ahead and hit OK. And that's how we come in and do the grab. Now, we do need to do a return still. So I'm going to go ahead and now go back and do a sub spindle return. And then we could actually keep that stopped during the return. We do want to unclamp the primary. And then we do want to feed back. So when it says feed, a lot of people confuse this. We're actually slowly moving back at a feed rate to that location. And then we'll wrap it back in the machine to our home position. So with that being said, is we're now roughing all the way down to our finishing cycles with that inside face bore. And then lastly, cleaning everything up based on a grab, return, and then a sub spindle move. However, there's one more step for the sub spindle that I forgot to tell you guys about, is when we actually go to the sub spindle side of things, you want to make sure that you have the secondary spindle selected. I know I talked about this a little bit, but if you do not do a secondary spindle in your actual setup, it's going to cause all kinds of havoc. Another quick tip here, guys, is you're probably also going to want to run a separate work offset in the sub spindle. So I could say, here I want to do work offset 2, which is G55. So before I go ahead and let you guys go, as always, if you guys love this content, don't forget to like, follow, and subscribe. As well, just know myself, Phil Brown here at JitCAD Cam, we offer custom one-on-one sessions as well as company-wide training, both online and in person. And if you guys have any questions about that, feel free to shoot me an email.